Okay, welcome back. So today I'm going to update the AI computer improviser by building out the communication with our sampler. So how I'm playing back all the grains in this patch is through this poly object here, which is the subject of a much older video in my channel that I'll link to, but it's basically a gen-based sample playback object, and it takes the start time, the end time, the gain, and the speed, and the window as a message, and that is used to play back a segment of audio from within a buffer. And it can play it back at different speeds. You can play it in reverse or forward. It has the pan built in here. It's a very efficient sampler. So it's what I'm using to play back all these grains when I click and drag on these plotters, for example. Yeah. So here we see the note message. So it's playing from 65,000 milliseconds into the sound file to 66,000 to 66,500, playing back at the full gain at regular 1-to-1 speed. The window shape is 0.8, which is more trapezoidal than sinusoidal. I'm using a 2K window function. And 0.5 is dead center for the pan. So I want to be able to get a little bit more granular in how I am communicating with the sampler. So right now, for instance, my when I click on the plotters, it's always in these 500 millisecond chunks for the or grains, I should say, for the granular analysis. And here it is always exactly the duration of the time between the onsets. So in this particular case, they're very short. Yeah. Also, right now, the speed of the playback, the gain, the window function, and the panning are somewhat static. So I also want to be able to have that be more dynamic, and I also want to be able to play these samples in reverse. Yeah, so that's the goal for today, is to build out that communication to be a little bit more interesting. So some of that I've already done, and I'll show that here because it's very straightforward. So this sprintf object is the one that makes our note messages to the sampler. So 1, 2, 3, 4, 6 floats: start time, end time, gain, speed, window shape, and panning. Yeah, and so I put in these objects so that we could change these whenever we like, the gain, speed, window, and pan. And then of course the start time and end time come from the KD tree queries. So if I was to just take advantage of these additions, I could make something like a pan randomizer. So I'm actually going to make a new file here and change these to send. And simply do this. Get our 4 inlets. One, 2, 3, 4, and I will save this as a note message. Okay, so now back to the sketchboard. Note message, and if we open it up, there we go. So I need to give it the appropriate name. So note message, MFCC slices, And let's also do a note message MSCC grain so we can switch between them rapidly. Okay, so let's begin by randomizing the pan, just as an example. So if we go random 100, so this will be completely random. We could use drunk to make it move gradually, but just for the sake of something very simple to mess around with at first. So divide it by 100 so that it scales between 0 and 1. And then that can go to our pan there. And now here, let's do it with a metro object. And throw that into there. And then we'll also want to accompany this with a node on object. But we will want to send, or not a node on object, but a query to one of the KD trees. So we'll want to send the pan info first and then the query second. So we're going to send a 2 decimal points that will correspond to the X and Y coordinates of our grid there. So for that, let's just do, I don't want to do something totally random. Let's use drunk for this one. So 105 and then divide by 100 again. So this will move more gradually. And so we'll need 2 of these. There and there. Then join that together. And then send this to tester, because that is going into to query from the 2D plotter for the grid one on the right hand side there. Whoops. So if I go here, will this work already? Yeah. Great, so we're getting random. Oh, my cat is trying to escape behind me there. That is getting random panning there. I'm getting little clicks here. I think it may be that I'm going to turn the signal size up a little bit. Okay. I have 2 copies of this open, which is probably why. Yeah, okay, it's working well. Okay, great. If I make it slower, it's going to be a little bit easier on the CPU. But yeah, I have a second copy of it open on my other screen, which is probably eating up a lot of the CPU. Okay, in any case, so that works. So we could do similar things for also the speed in the pan. So, you know, playing around with the playback speed, we'll change the pitch. So if we do another random 100, and then maybe divide this by a larger number, like 1,000. And then what would we do? We would add this to 0.99. Let me see if I have the right number of decimal points here. Yeah. All right, so this will just sort of add a little bit of jitter for the playback speed. The speed is, hold on. Let's spread these out a bit so I can read it. The speed is a second input there. and the pan. All right, so let's do that for the speed. And then I think for the gain, let's do something a little bit more extreme. I think maybe let's do 0.85 there. All right, so that's speed. Gain window we won't mess with now, but we could make it the playback be a little bit more smooth sounding, especially with the grains if we change the window shape. Okay, so we'll have a random pan and a somewhat randomized speed of the playback as well as loudness. Great. Yeah, so we start to hear maybe some of the possibilities by changing these things. Okay, so that is now the only that builds out our note messages a little bit. Now I do want to add a couple of more options. So let's go into the grain playback. And what I'd like to do here is make it so that we could play back longer durations than the analyzed grains. So this is simple enough. Oh, and we also want to be able to play the grains in reverse. So let's do the reverse function first, and then the sort of time extension second. So the reverse function, I'm going to do this by gating the signal or gating the message, and having the default when you launch the patch be it being played forward. So we'll just go like that. And then the reverse is simply this. Oops, sorry. Like so. And then joining together. So we'll get the larger number followed by the smaller number. So it will be played in reverse. And that's all there is to it there. Now, in order to create the extension, well, why don't we actually test this first? So we'll need let's say direction. Of course, that should be a receive object. Going into here. So if we go back to our scratch pad, now this could also be worked into the note message object. In fact, it should be. So why don't we go ahead and do that. So here we have direction. Oops. And let's go ahead. We'll also need an extension as well. Extension. Okay, go ahead and save that. So direction is there. So let's just have that go in reverse. Oh, actually, I want to do it with the grains because it's a bit longer. And that's what I just added to it. Okay. So if I've now hit that, now we should have this one open. Hold on. MFCC grains. Let's see. Currently closed. Currently open. Direction. MFCC grains. Direction. Underscore direction. All right. Let me just get back into here. Yep. 2. Back into here. Direction, okay. Grain direction, not grains. I think that's my mistake there. Yeah, MFCC grain, all right. It's a typo. All right, great. That has that wonderful backwards guitar sound to it. Okay, so now we just need the extension. So this is simple enough. So we'll be adding in milliseconds to here in order to extend, in order to extend our note message when it's played forward. And we will need to actually subtract here in order to have the reversal go further, because I always want it to start from the point that's called and then work backwards from there. And the reason why we have the +1 there is so that it's the same grain as it's been analyzed, but I want to extend it in time at the end of the message instead of at the beginning. Extension. Okay, so now if we go back to here, we have our extension as well. So let's do it. Let's add a whole 1000 milliseconds. So now it'll be 1.5 seconds reverse samples. All right, so that is not, that has not worked. Let me see, MFCC grain. MFCC grain extension, MFCC grain extension. Let's check this. 1000. Okay. There we go. Okay, so our samples are longer. Okay, so that is, all right, that's looking good. So from here, we can also add some randomization, very easily add some randomization to our grain sizes, and we could randomize or have it played in reverse as we like. My cat's really trying to escape out the window there. She wants to be an outdoor cat, but we promised Humane Society that she wouldn't be. Okay, great. So that's it for building out our make note for the grains. So we'll want to do the same thing here for our slices. It's going to look slightly different, but very similar still. Let me just compress that a little bit. Oops. So again, we'll want to have a gate here for playing it forwards or backwards. So that is playing it forwards. There. Load mess. 1, so that is playing forward by default when it opens. And then this is going to look very similar, the only difference being that the +1 goes goes first. Yeah, like this. Or rather goes on the left. Actually goes second, of course, because in Max we go from right to left. And then we join them up here, like so, and send them to the sprint F. And there. So now we can play our thing backwards here. We can just, yeah, so all the samples are in reverse now. And then we want to be able to extend them. Now I want to have actually 2 options for extending this type of message, the one with the onset slices. I want to be able to just add an entire slice, and I also want to be able to manually add milliseconds. So adding the milliseconds, we have the same thing that we did earlier, where we want to add on this side for our forward direction and subtract on this side for our reverse playback. Okay, so so this is direction at the top. Oh, that shouldn't have worked earlier, or maybe it was just in my head. Oh, there we go. Okay, that's definitely working now. And here we go for extension. Okay, let's see if that's working. Actually, I'll make it noticeably longer, half a second. Yeah, great. So that's working. And you see like very different kind of vibe with the longer samples, but we're still getting them at the onsets, which is kind of cool. And then now I want to be able to increase it so it plays to the following onset. So let's see, add slice, and that would simply go here, and let's see, how do we want to do it? Oh, the best way to do it here, because we always want it to start at the same point. If we did this here, there. Okay, so that should do it. In fact, we should have note message, slice, and then note message grains. So if I change this to note message, slice, then we can have also, what do we call it? Add slice. Add slice. Cool. So now let's have this, and that would stack with the extension of the time. So let's play it in reverse, 0, and let's play 3 slices per. Now I'm not sure if it's working, so let's actually try something more ridiculous like 10. Alright, now I'm not confident that that's worked, so let's do a little sanity check here. Alright, add slice, MFCC slices, add slice. Hold on. Perhaps if that needed to be saved. Oh. I see what I did here. I'm missing my little ones here. It's odd because the extension worked before, so I must have deleted it by accident or something. I'm not sure what happened there, but in any case, now it ought to work. So let's do 3 slices. Let's not get carried away. Yeah, it sounds longer. 5. 10. Yeah, you can hear the shift back to 1. Great, so that could be very useful. Now, a way that we can sort of call back defaults that I think would be good to implement right away is just to make sure that we have these load mess objects that are giving the defaults for when we launch the patch. or load banging in messages like that is fine as well. For that, there, and there. And then we could have an R init, a sort of global initialization object that is going to hit all those objects. Or actually, we may want, hold on, we may want a global initialization as well as a you know, per corpus, or not per corpus, but per analysis initialization, per playback type initialization. So that can go into both like so. Great. So I'll do the same for the, oops, there we go. I have this weird bug on this machine where it does that. Okay. Great. So that looks good. I don't need that. So once again, I will clean this up. I will also add this initialization to the MFCC grains, and I will make sure that it's in all of the different analysis objects, and then update the GitHub. Okay, so that is everything I wanted to do today for building out the sampler communication. And yeah, so now we have a lot more interesting ways to sample our corpus, or more robust ways to sample our corpus, which hopefully will be useful as we get into making our AI computer improviser actually play with us and make music. I swear we'll get there eventually. Great. Okay. Thank you.